Okay, for this problem, the task is to find the current IX. We can see where the current IX is labeled in the circuit. This is a single node pair circuit. So we're going to use the problem solving strategy for single node pair circuits and the problem solving strategy for circuits with dependent sources. And our first task, if you'll refer to the problem solving strategy, is to define a voltage. And I'm going to define a voltage V1 with this polarity. I could have defined it with the plus on the bottom, but I'm going to define it with that. So there's the first step. The second step is to write currents through resistances in terms of that voltage using Ohm's law. So for instance, we have V1 over 2K, V1 over 5K, and V1 over 10K. So I've made that definition in terms of the voltage V1 using Ohm's law. Now we have one unknown voltage V1. We're going to apply KCL at one of the two nodes to come up with that equation, and I'm going to use the top node. Okay, and let's sum currents leaving that node and set it equal to 0. Okay, so we have 10 milliamps entering, so that's minus 10 milliamps leaving. We have a dependent source, current 2Ix. Now, if you remember from our strategy for circuits with dependent sources, we're going to treat that as an independent source while we're writing the equation. So this is minus 2Ix. Then we have V1 over 2K leaving. We have 3 milliamps leaving, and that's at source. Then we have V1 over 5K leaving, V1 over 10K leaving, and by Kirchhoff's current law, that has to equal 0. So if we collect up terms, we can rearrange the equation to be the following. Now, referring to the strategy on circuits with dependent sources, now I need to express Ix in terms of that voltage V1, and where I'll do that is I will apply Kirchhoff's current law at this connection. Okay, and I'm going to sum currents leaving that node, and if I do that, I'll have Ix plus V1 over 5K plus V1 over 10K, and by Kirchhoff's current law, that has to be 0, so I sum currents leaving that node. So now we get Ix is minus V1 over 5K minus V1 over 10K. Now, let's substitute this in here. So now we have V1 over 2K plus 1 over 5K plus 1 over 10K. We have minus 2 times minus V1 over 5K minus V1 over 10K is equal to 7 milliamps. And if we collect up terms, simplify sum, we'll have V1 times the quantity 1 over 2K plus 3 over 5K plus 3 over 10K is equal to 7 milliamps. And we need to continue to simplify that so we can solve. So let's multiply through by 1,000. If we do that, we'll have V1 times the quantity of half plus 3/5 plus 3/10 is equal to 7. This is V1, and this term in parentheses reduces to 14 over 10 equal to 7. So then V1 is equal to 5 volts. Okay, so there's our voltage. And now if we look back at our equation for Ix, we had Ix is minus V1 over 5K minus V1 over 10K. So here we have minus 5 over 5K minus 5 over 10K. So that's minus 1 minus 0.05, which is minus 1.5 milliamps.